Hi, are you a student or a parent or guardian of one? I have good news for you. Watch this video till the end. What if I told you that mathematics, your nightmare, is one of the simplest subjects there are? I will likely top your list for the biggest jokers of the year, but give me just 5 minutes to convince you. One day after a mathematics class, a student walked up to me and asked me, "Sir, how come about this mathematics that we solve?" I told him they must not have come from nowhere. They must have come from somewhere, most likely real life scenarios, and the methods for solving them are likely real life approaches to these problems. From that moment onward, I embarked on an adventure to finding mathematics in the real world, and I discovered that mathematics is all around us and everyone is a mathematician. So I pondered, why then is it difficult to teach someone what he or she does daily, or to simply show him or her what is all around us? I realized that we were not really taught mathematics and science. Now let me show you mathematics in 3 minutes. Mathematics is just a language, and just as the spoken languages use symbols and signs to record sounds and speeches, mathematics uses symbols and signs to record counts and ideas. Everyone is a mathematician. From childhood, we start learning how to count and how to record our counts with symbols. We gradually proceed to combining numbers by the rules of addition, subtraction, multiplication, division, and so on. And gradually, we proceed to finding missing numbers. Say, we want to buy a wristwatch that costs 1,000 nairas and we have 300 nairas. How much do we need to buy the wristwatch? And if we have 300 nairas and we are able to save 100 nairas monthly, how many months will it take us to buy the wristwatch? Note that the numerals are symbols invented by man for recording known numbers. We can likewise invent symbols for recording unknown numbers, or better still, we borrow the symbols of the spoken languages. Say, we replace the question marks in our statements with X and Y respectively, so that our statements become 300 nairas plus X nairas gives us 1,000 nairas for statement 1, and 300 nairas plus 100 nairas monthly for Y months gives us 1,000 nairas for statement 2. This, representing unknown numbers with symbols, allows us to represent just about anything with symbols. For example, we can represent the length and the width of a field with symbols L and W respectively. This enables us to quantify the peripheral length and the size of the field, as perimeter P is the length plus the width plus the length plus the width, which is 2 times the length and the width of the field, and area A is the length across the width of the field. Also, such relations allow us to track changes in numbers, such as, for example, how and by how much the perimeter and the area of a field change with respect to the length and the width of the field. In most cases, these relations are derived from statistical data obtained over time. Say, we just welcomed the baby into the world and we are super excited how time flies. We were babies yesterday, today we have a baby, and one day our baby will grow up to be like mom and dad. And in our excitement, we decided to track our baby's growth. On every of his or her birthday starting from birth, we make him or her stand up against a wall and mark his or her height on the wall. And suppose after 3 birthdays, we obtained the following hypothetical graph. This graph encodes details of our baby's growth, and there are a few important questions we can ask of this graph, such as, how fast is our baby growing? What was our baby's height at birth? And what will be our baby's height at a given age? To answer these questions, we need to establish a relation between our baby's height and our baby's age. And from the graph, we can see that our baby's height at birth was 10 units of height, which increases by 5 units on every of his or her birthday. Hence, our baby's height at any given age is the height at birth plus 5 times the age of the baby. We can extend this to a larger population of babies. Say, we want to investigate the growth pattern of babies nationally or globally. To achieve this, we need to obtain the heights of a sample of babies born the same day on their birthdays and plot them against their ages. However, all babies born the same day do not have the same height. So we will need to obtain the mean height of the sample of babies on their birthdays and plot them against their ages. And because all babies born the same day do not have the same height, there will be deviations from the mean in our analysis. These are the 5 basic aspects of mathematics, namely numbers theory, arithmetic, algebra, geometry, and analysis, as simple as 1, 2, 3. Upon this realization of how simple mathematics and science are, I took the challenge to rewrite the books and make mathematics and science playground simple by deriving the equations and concepts from real life scenarios. And those 7 years of bone-crushing hard work and sleep when you are dead dedication have culminated in arguably the most simplified mathematics and science textbooks you can possibly find. Simplified General Mathematics for Senior Secondary Schools, Simplified Further Mathematics for Senior Secondary Schools, Simplified Physics for Senior Secondary Schools, and Chemistry Guide Theory and Practical for Senior Secondary Schools by yours truly, Joseph Oshoma Asuke, available on Amazon and local online and physical bookstores. You can as well access these materials plus free mathematics and science lessons and personalized prep packs comprising over 1,000 thoroughly explained self-practice problems on my website www.everydaymaths360.com, or my YouTube channel and Facebook page at everydaymaths360, or on WhatsApp 081 32728230. I hope to see you at the top of your career ladder. Thank you for watching.